Alright, so hello and welcome. In this video we are building a machine learning model which outperformed the S&P 500. I've visualized how the model is working here. Your input are the previous n-day returns, so t-1, t-2 and so on, which are fed into a model predicting the probability of the next market movement. Then I'm testing if you would follow those predictions, how the overall performance would look like. Some words on the model. Model is a logistic regression. The independent variables are previous day returns, which I will call lagged returns. So the lag 1 return is the previous day, the lag 2 return is the return 2 days ago, and so on. The dependent variable is the market movement, which is up, so 1 when the market return is positive, and down otherwise. The model is labeling the output as 1 if the predicted probability is above 0.5, as you see on the picture on the right, and will label as 0 if the predicted probability is below 0.5. Important disclaimer: concepts shown in this video are not an investment advice. Video is for educational and entertainment purposes only. Additional remark from my side: take this with a grain of salt. Alright, let's get started. We need some libraries. Why finance to get price data for the S&P 500, NumPy for data handling purposes, and logistic regression from the sklearn library, which is our model. First, I'm going to pull price data for the S&P 500 using YF's download function and provide the ticker symbol for the S&P 500. And I'm starting my analysis in the beginning of 2010. With that, I'm getting a data frame containing daily open, high, low, close data. And as you see, starting in the beginning of 2010, going until the last trading day. Next, I want to have returns. So I want to have the relative change of the close price of the S&P 500 daily. To do that, I'm creating a new column, so which is appended to that data frame. Use the close column and apply the PCT change function. With that, I'm getting a column containing the relative price change. So this in relation to this. And as you see, the price was rising, so the return is positive here. Next, I'm setting up a function which is calculating my lagged returns, which I explained in the beginning. So what should this function do? Let's take an example, but I will show you in more detail once we have set up this function and called it. But for now, take this row here. On this row you have this return here, right? You also want to know the previous day return, so the lagged 1 return, which is this return, right? Simply the return the day before. So I need to have a function which is creating a column for me here containing the previous day return in the same row as my return for that particular day. So I simply want to have this value right besides this value here. And how can this happen? By simply lagging this one row in front and then just create a new column here. Right, and this is exactly what we are going to do. And we are going to keep it flexible. So I don't only want to have the lagged 1 return, but also the lagged n return, meaning the 2-day previous return. So take this row, for instance. So this one, you want to have the previous day return, which is this one. So that would be here. But you also want to have a column containing this value here, and also in the same row. So you have a lagged 1 return here and a lagged 2 return here. And this is basically scalable until whatever makes sense, right? 3 days, 5 days, 10 days, whatever you like. So let's set up this function. I'm going to call that lagged, and this is taking a data frame as an argument and a number of lags you provide. So 1 for only the previous day return, 2 for 2 days, 3 for 3 days, and so on. And within this function, I'm looping for I in range 1, because I want to start my loop at 1 because there is no 0-day return. And I'm going until the number of lags I provide. And I have to add a 1 because Python is not including the stop element of a loop, right? Just as a reminder, if I'm taking for I in range 1, 2, 3 here, I'm only getting 1 and 2. So if I'm adding a 1 here, I'm also getting the 3 here, right? Just a quick recap in case you forgot. Okay, so this is my loop, and now what do I want to create? First, I want to create a new column here. So I want to have a column which is leg underscore and then the number of the leg. So I'm taking the element of the iteration, which is 1 in the first loop, and then I'm just providing the I here. So in the first iteration, I said this is leg underscore 1. In the second iteration is leg underscore 2 and so on. So this is creating a new column. And the content of the column should be my return column, but shifted by the leg. So in this case, I'm creating a new column here, leg 1, and I'm shifting this return by 1 row. So with that, I have this return right beside this return, right? So I'm taking df red and shift it by I. So in the first iteration, I'm shifting it by 1, in the second by 2, and so on. So in this row here, I would get the leg to return column, which is this one, because I shifted it by 1, 2 rows here in the second iteration. Now, I also want to have the legs I created here. So simply the names. Why? Because my legs are also my features of the logistic regression, right? And I simply want to have an output of my feature names here. So I'm returning and basically do this step again. So I'm taking return, use the list comprehension here, leg, string I, for I in range 1, legs plus 1. So this is simply providing me whatever legs I'm putting in. It is providing me a list of the legs which are simply my feature names, right? So of course you could also solve that within this loop here, right? Maybe a better practice here, but I like list comprehensions more. So you could also just work and append to this list here and just return the list. Also possible, right? Just as a side note. But for now, I messed up somewhere. Leg, of course, plus string I here, right? So let's call this function and let me show you exactly what this is doing. So let's take 2 legs here. So first of all, it is returning me a list here, right? Of the 2 features, because I have 2 legs. Now I have a list of my feature names when I create 2 legs here. Simultaneously, it also extended the data frame. So let's take a look at our data frame, and you see we have 2 new columns, leg 1 and leg 2. And now let's take a look at that in more detail again. So let's take this here. On this day, I have this return, and I have my previous day return here, which is now right besides that in the same row here, right? On this day, I have this return. I have the previous day return, which is this one here. And I also have the previous 2-day return, which is this value here, right? So worked like a charm. So I have in every single row, I have my previous day return and the previous return, okay? Now, as we are working with a logistic regression, so these are my independent variables, right? Leg 1 and leg 2. And I want to apply this logit regression and take those independent variables and predict my dependent variable. My dependent variable has to be binary. Currently, it isn't. Currently, I have a return here. So I want to transform my return value or my return column to a binary column. So I want to have 1 here when my return is positive, so the market went up, and I want to have 0 when the market went down. So let's create a column here, direction, and now take numpy where and check for return, which is larger than 0, so the market went up. Then I want to have a 1, and if the market went down, I want to have a 0. So with that, I have a new column here, which is containing the direction. So for the NAN values, we are getting rid of them in some seconds. It doesn't make sense, but for this, it makes sense. So on this day, we have a positive return here. So the market went up. So we have a direction of 1 here. On this day, we have a negative return. So we are getting a 0 here. Same for this day, 0 here. And then the market is moving up again. So we're getting a 1 here, right? Now, when you're using or when you're working with logit regression, you have to be cautious of your data set. So if I'm taking a look at the direction column now and count the values, so how often was the market going up and how often was the market going down, you see there is kind of an imbalance here. So you have more up moves than down moves here, right? And even a slight imbalance, a logistic regression is very sensitive with that. I'm taking care of that when instantiating the logistic regression, but just as a side note here. Okay, now we have created our legs, and I want to store those created legs in a variable which I'm calling features. So features, independent variables, is synonymous, right? So I'm taking legit here and just let's take 3 days here. So with that, I have stored my feature names in a variable here, leg 1, leg 2, leg 3. And as you see, I also have leg 1, leg 2, and leg 3 stored in my data frame. Now, I have a lot of NaN values, as you saw, and I want to drop them. So I'm just taking drop NA and in place them so that I directly have them deleted in my data frame. So with that, I don't have NaN values anymore. And I can start with building my model. So we have independent variables, which are our lagged returns, and we have our dependent variable, which is our direction. So market movement, up or down. So I'm just sticking to the usual notations. So X is are my independent variables, and my X is simply my data frame filtered for the features. Makes sense, right? Because my independent variables are just my lagged returns. So from my lag returns, I want to regress to if the market is moving up or down. Or in other words, in more correct words, what is the probability of a market going up or down? So I have my independent variables here, and now my dependent variable is quite straightforward. Just Y here, and then this is just the direction. So just market went up or market went down. And now I can set up my model. So I'm going to define my model as logistic regression and set the class weight argument to balanced to take care of the imbalance of the data set. So with that, I've set up my model, and now I'm fitting it to my independent and my dependent variable. Getting a feedback here. That's actually quite new. I don't know what that is about, but it just told me that my model has been fit to my independent and dependent variables. And now I want to make predictions with my model, right? So I'm going to create a new column to my data frame, calling that prediction logistic regression, LR, and use model predict X. So this is looking like this. You want to predict, and then you're getting an array of your predictions here. So if I'm executing that, I'm getting the prediction of my model, and I can actually just compare that to the direction of the market. So this is what my model was telling me. So on this day, it actually told me the market was going down, but the market was actually going up. On this day, the model said going down, market was going up, prediction was accurate here, prediction was right here, and so on, right? So I'm not doing accuracy and other measures in this video. I've done that in some previous videos. I will try to link them in the video description, or will do that in the follow-up video. For now, I wanna calculate the return of the strategy if I would stick to my model, right? So how would this work? Whenever my prediction is telling me the market is going up, I'm invested in the S&P 500. So I simply take the return of that day. So I can simply multiply this column, prediction LR, with my return column. So I'm getting the return if it predicted 1 here, and I'm not getting a return if it predicted 0 here. All right, so I'm calling that column strat for strategy, and use my prediction logit regression model and multiply it with my return column. So with that, as said, I'm getting a 0 return if the model said I should not be in the market, as you see here, and I'm getting the return if the model said I should be in the market. Right? And to evaluate it now, I accumulate those returns, right? So I'm just comparing that with the development of the S&P 500 by comparing the return column with the strategy column, okay? So I'm only in the model, I'm only invested when it has 1 here, and then I'm accumulating the returns. So let's do that. Let's take the strat column and the red column, add a 1, and take the cumulative product. This is simply accumulating returns. I've covered that in another video, which I will link in the video description. And this is giving me an insane return of, let's subtract the 1 here, sorry, of 400% versus 250% of the S&P 500 since 2010, right? Which is quite insane in the first place. So let's take a look at how this would look like in the chart. So you see my strategy, right, is clearly outperforming the S&P 500. Now, is this too good to be true? Yes, because I created the model on the whole data set, right? This is called overfitting in machine learning, in trading, and every other data science, data analytics discipline here. So I cannot create a model on a whole data set. So what can I do? I can split my data set, which is going from 2010 until today, or the last trading day. And I can just train the model on only a slice of the data set, and then check if the predictions on that trained data set is actually still outperforming the S&P on newer data. So I'm splitting the data set by using from sklearn model selection, import train test split, and then create an xtrain variable, which is containing my independent variables training data, then my independent variables testing data, my dependent variables training data, and my dependent variables testing data. Calling train test split. I'll show you how this is looking like in some seconds. Apply that on X and Y. Take a test size of 30%. That means that I'm training my model on 70% of the data, and I'm testing my model on 30% of the data. And then very important here, as we're working with time series data, I want to set the shuffle argument to false, because when splitting the data in a time series, you have to take subsequent data, right? It doesn't make sense to train the data on mixed data here. So you want to have, let me show you the data frame. You want to have the X rather. You want to have the data from 2010, let's say, to 2018 on the training data where you train the model on, and the rest for the testing data, right? You don't want to have this date, then this date, then this date. It doesn't make sense on time series data. It does make sense on other forms of data, but not on time series data. So with that, I'm just slicing this data set at 70% of the data. So it simply takes this, the number of rows takes 70% and takes that as training data and the rest as testing data. So let's take a look at how this is looking like. Let's execute that. So the training data is going until somewhere in the beginning of 2019, and the testing data is going from that point in time until the last trading day, right? So this is how it looks like. So we have it, same for the training, the dependent variable training data and the dependent variable testing data, right? So it is sliced until 2019 and rests until today or the last training day. So what is the idea now? I'm taking my training data and train the model or fit the model to that training data, and then actually test that on my testing data and see if I'm getting better or worse results. So our model is still our logistic regression model, so we can fit it on the training data. So just take X train and Y train here, so independent and dependent variables here, getting the feedback that it fit. And then we are just using the X test data, which is our testing data. And then we're doing what I did above, right? So we're just taking the prediction, logistic regression, so adding a column here to the test data, and then use the model we just fit to the training data and predict X test here, of course. And then we can compare, right? So of course we need to pull the return data from our data frame, right? Because the test data currently doesn't contain the return data, which is in the data frame. So I need to filter the data frame return data for only the test data set, because I need the returns for only the test data. So how can I do that? I simply create a new column, red, use the return from the data frame, which is the unsliced data, and then I just filter for only those where the index is larger than the first date in the test data set. So what I'm doing here, I just take this date and filter my return data frame for the returns from this date on. And with that, I'm only getting the returns on the test data set. Nothing more than that. So I'm showing you. So with that, I'm just getting my returns for that time frame here. So with that, I can again calculate my strategy's return, same logic. I'm just taking the models predictions times the return, and then take a look at that again by filtering for the strategy and the return +1, then the cumulative products, subtract the 1. So interestingly, when splitting the data, you see that the strategy was actually rising by 122%, sorry, and the S&P 500 was rising by 45%. You're right, to visualize that, you have it here. So even after splitting the data, the model does a quite good job. You already see where it is coming from here. So yeah, but be cautious, right? So I can show you, for instance, if you would take this model. So let's say you traded this model the last 50 days, right? You see that this one was the S&P 500. The S&P 500 would outperform this model, right? So yeah, but quite a nice thing to check out here. So as always, just a play around here, right? But quite impressive, even after after splitting the data, you still get some outperformance of the strategy over the S&P 500. Important remark here, of course, is that you have to take the turnover into account, right? Because currently, when you are buying the assets, so at this point, it tells you stay out. But at this point, you should be in the market, right? So whenever this is changing, there are transaction costs coming up, right? Of buying the S&P 500 and also selling the S&P 500 when you are exiting, right? So whenever this is changing here, there are transaction costs coming up. So you have to take that into account as well. So, but yeah, I think quite an interesting thing to check out. So of course you can do some other stuff here. So for instance, I don't know, increase the lags and see how this is turning out. So let's only take at the splitted data here. So increasing the lags. Obviously does not have a big impact here. Anyhow, I want to cut the video off here. What I recommend to do here is to take a look at performance metrics. I will link a video where I did that. It's very important when taking a look at logistic regressions. Thank you very much for watching. If you're interested in similar topics like this or other machine learning models, let me know below, leave a like. Thank you very much, and I'm looking forward to see you in the upcoming videos. Bye bye.